Now let's study the law of conservation of matter in this video. Now this is the first of the law of chemical combinations we are studying. Now this law states that during a chemical reaction, matter is neither created nor destroyed. Again, during a chemical reaction, matter is neither created nor destroyed. That is, you see, when you have a chemical reaction, have something in mind. A chemical reaction have this pattern: reactant reacting together to form products. Let me say, for example, you want to cook now and you are getting your ingredients. Let me say you want to get ingredient now to cook rice. Let me say concoction or jollof. You have your tomato, pepper, rice, vegetable oil. All these are the reactants. Now after you cook everything together, prepare everything together, and the food is ready, what you have is the product. That is just chemical reaction. Now in a chemical reaction, that is, matter is not created, matter is not destroyed. It means that what? Matter are just rearranged. That is, they are just being transformed from one form to another. That is, the total amount of matter I'm having at the beginning is the same as the total amount of matter I'm having at the end. Therefore, they are not created and they are not destroyed. That's the meaning. The amount of matter at the beginning is the same at the end. Nothing is created, nothing is destroyed. Good. This law is stated by a scientist called Lavoisier. Lavoisier is that scientist that named oxygen oxygen. He was one that named hydrogen hydrogen. Okay, remember the history. Don't worry, when we get there you understand that better. Now let us now explain what does it mean. Explanation, further explanation for you to understand this law is that what? In a chemical reaction, total mass of the reactant is equal to total mass of the product. It means that nothing is created and nothing is destroyed. That's the law of conservation of matter. Now take note that what? Atoms are only rearranged. They are not lost, they are not created. Let me give you an example. If I have this equation, NaCl going to NaCl, you can see they are just being rearranged together to give me another substance, which is the product. These are the reactants. You know, they will rearrange each other to give me what? This product. So that's the law of conservation of matter. That is it. Now pay attention to something very important. When you want to verify this law, take note of something that what? All balanced chemical equation obey the law of conservation of mass. Yes, take note that you will still learn how to balance chemical equation as we move on in this video. You will learn how to balance chemical equation very well. If you don't know it before, you will know it in subsequent video. Now let's move. If an equation is not balanced, you see this law will never hold. This law will not hold. So law of conservation of matter hold whenever you have a balanced chemical equation. Are we together? Good. So that is that about that. So take note that what? It is the law that total mass of the reactants is equals to what? Total mass of the product. That is what everything here is saying. So that's that for that. Thanks for watching. Now let's look at the verification of the law of conservation of matter. Remember I told us that a balanced chemical equation will obey law of conservation of matter. Okay, let's see. Look at this equation that you have here. Check out this equation. You have H2 plus O2 to give me water. Hydrogen, oxygen to give me water. This is what you have in the first one. The second one, you have the same equation in another form like this. You have what? This is what you have. And take note of something, that you have been given the mass. They give you that the mass of hydrogen is 1 and that of what? Oxygen is what? 16. All these are the atomic mass. Now what we are going to do is that we are going to calculate the total mass of the reactants here and calculate total mass of the product. So for the reactants, you know hydrogen is 1 and you are having 2 atoms here, so that will give me 2 times 1. This 2 is coming from here and hydrogen is 1 from here. So let's go. Plus what you have here is 2 times what? Let me do it this way. You have 2 times 16. Oxygen is 16. So what will this one give you? This one will give you 2 plus 2 times 16 is what? 2 times 6 is 12. 2, that's 32. So this will give me 34. That's for the total reactants. But let's look at the product. What do you have here is what? What you have here is 2 hydrogen. That's 2 times 1. Also plus, how many oxygen do you have? I'll add the one for this and this together. Oxygen is 16. So add together, you have 2 plus 16 will give me what? 18. But check, total mass of the reactants and total mass of the product are not the same. So this one do not obey law of conservation of matter. Why does it not obey? If you observe, the equation is not balanced at all. How will you know it's not balanced? Here I have 2 atoms of oxygen, and here I have 1 atom of oxygen. Oxygen is not balanced. Although hydrogen is balanced, hydrogen is 2 here, also 2 here. But since oxygen is not balanced, therefore this equation is not balanced. It cannot obey law of conservation of matter. Okay, let's look at this one. Now, if you observe this, I'm having 4 hydrogen. You know, these 2 times these 2, that's 4. You know, these 2 times these 2, that's 4. Then hydrogen itself is 1. That's 4 times 1. Then plus, here I have 2 times what? 2 times 16, and that's 32. So this will give me 4 times 32, and my answer is what? 36 grams. That's what I have, 36 grams. And just put grams. Okay, let's look at this one. Here I have these 2, we multiply all of them. So I have 2 hydrogen, 2 times 1 for hydrogen, plus 16 for oxygen. So this give me 2 times, that's 2 plus 16 will give me 18. 2 times 18 will give me what? That's 36 grams. You can see 36 grams and 36 grams here are the same. Therefore, law of conservation of matter is what? Is obeyed here. Is obeyed here because this is a balanced equation. It is not obeyed here because this equation is not balanced, and that's that for that. Now, the next one is law of definite proportion. Now, this law states that all pure samples of the same chemical compound or of the same compound contain the same elements combined in the same proportion by mass. What does this law mean? Another way you can call this law is what? Law of constant proportion. Are you there? We can also call it what? Law of constant proportion. It can also be called law of constant proportion. Also, take note that what this law was stated by Proust. Good. Now, let's talk about the idea of this law. Look at what it's telling us again. It's telling us that what all pure samples of the same chemical compound have the same elements and they are combined in the same proportion by mass. Let me tell you a story. If method A, let me say method A was used to produce this compound H2O called water. Method B is used to produce another method B is another method that is used to produce water. Firstly, you can observe something that no matter the method you use, if you are producing the same compound, that same compound will contain the same element combined in the same proportion by mass. Look at it. Someone used method A in another country, they got H2O. No matter where you are, if you produce H2O, you still have what? H2O. Okay, let's see something. Remember I gave you the masses of hydrogen to be 1, oxygen to be 16. Now, if you look at the mass of this, if you calculate it, you have 2 times 1 plus 16 for oxygen, and that will give you 18 grams. Are you there? This one will also give you what? Okay, let's do it this way. Let's us look at it in terms of ratio. Now, what you want to do here is that we'll check the ratio of hydrogen to oxygen. The ratio of hydrogen to oxygen. Now, check hydrogen you have here. You know, 2 times 1, that is 2 ratio. Oxygen is how many? 16. So 2 here 1, 2 here will give me what? 8. 1 ratio 8. Now, look at it. The ratio of hydrogen to oxygen by mass in water is 1 ratio 8. Now, this law is telling you that no matter the method you are using to produce the same elements, they have the same proportion by mass. That is, they have the same ratio by mass. That is, if you look at this one also, you also have 1 ratio 8. That's what it's telling you. The basic idea is that what? No matter the method, you see that it's possible that, look at this compound. This compound is called copper 2 oxide. It's called copper 2 oxide. Now, we have several methods to produce copper 2 oxide. We have about 3 or more than 3. Now, no matter the method you are using to produce copper 2 oxide, the ratio of copper to oxygen by mass will always be the same in all the compound. If it's not the same, then this law is not obeyed. That is what it's telling you. I believe that is clear. Thanks for watching. Now, let's verify the law of definite proportion. So let's look at this question. If 1.8 gram of a metal oxide, on analysis, you see you have a metal oxide here. So on analysis contain 1.40 gram of metal. and 4.50 gram of another sample of this same metal oxide. So look at it now, I'm having metal oxide here and also here. So what will I do? So let me say that I have sample A, and I have sample B. We are looking at the same metal oxide, have you now? So they are all metal oxide. So sample A, sample B. Now sample A is 1.80 gram and sample B is what? 4.50 gram. So let's get the question from beginning. If 1.80 gram of a metal oxide on analysis contained contained what? 1.40 gram of the metal. We are looking at a particular metal here. Well, let's look at, okay, this one contain what mass of the metal? 1.40 gram of metal. And 4.50 gram of another oxide that you have here on reduction gave 3.50 gram of this same metal. So the metal under sample B here is what? 3.50 gram. Now pay attention, sample A is this, sample B is this. On analysis, sample A was 1.40 gram. On analysis, sample B was the metal in sample B was 3.50 gram. Now, then that's us to show that if this law obey law of constant composition, that's law of definite proportion. Now pay attention, the easiest way to verify is this. Remember that if we produce the same chemical compound, for example this metal oxide, in two different ways, let me call those ways sample A and sample B, pay attention that they will contain the same elements in the same proportion by mass. Now the easiest way you can just verify this is that calculate the percentage of the metal here and calculate the percentage of the metal here. If the percentage of the metal here and here are equal, therefore it has obeyed law of definite proportion. Remember, since it is different methods, we must have the same thing. Now let's go. So percentage of metal in sample A is what? Remember, percentage means mass of the metal over mass of the sample times 100. That's how we find percentage mathematically. Percentage of metal in B. What do we do? Mass of the metal in B over mass of B itself times 100. So what would this one give us? Please get your calculator ready. Let me just get mine ready here. So I have 1.40 divided by 1.8. So multiply that by 100, I'll have 77.78%. And secondly, here I have 3.5 divided by 4.5. Then times 100, I have 77.78%. You can see, since the percentage of the metal are the same, therefore, law of definite proportion is agreed. So you verify that with a statement. Okay, so that's that for that. At times, it might not be the same thing exactly. It might be approximately the same. You can just have a very small difference. If you observe that, it is also obeyed. But if it is totally different, then it is not obeyed. Thanks for watching. Now, in this lesson, we want to study the last chemical law called the law of multiple proportion. It states that when two elements A and B combine to form more than one compound, or combine to form two or more compounds, the various masses of one element B, which combines with a fixed mass of the other element A, are a simple whole number ratio. Now let us explain what this thing is saying. Now it is possible for more than two elements to form more than one compound. Explanation: look at carbon and oxygen. Look at it. Carbon can react with oxygen to form carbon 2 oxide. This same carbon and oxygen can react together to form what? Carbon 4 oxide. Look at it. It is possible for me to have the same element with two different compounds or two or more compounds. So whenever you observe something like this, even without verification, just know that we are talking about law of multiple proportion. For example, if I'm talking about XCl, XCl2, XCl3, look at it. Two elements combine to form more than one compound. And so look at it. XCl, XCl2, XCl3. And what this law is telling you is that let me say this one is A and B. This is A and B. this A and B, you can see A and B combine to form two or more compounds. Look at it here. Then that's like the various masses of B, that is, look at B is changing. Look at it from 1 to 2 to 3. You can see that's why they are using the word various or the word several masses of B. That is, B is combining in different ways. B is changing. Then that's what with a fixed mass of A. You can see that A is not changing. Just look at it. Carbon is not changing. So this X is a fixed mass. Then that's that the various masses of this B reacting together are in simple number ratio. Now, can you tell me the atom of this one reacting together is, let me just say 1 ratio. The one reacting here is what? 2 ratio. The one reacting here is what? 3. And that's a simple number ratio. If you observe this in an objective question, you don't need to verify. Just take note that it is law of multiple proportion. Now let us do some verification now to explain. Let us do some illustration. Now let's see. Take note that the mass of carbon is 12 and that of oxygen is 16. You have been given here. Now, if you observe, carbon and oxygen here, they are in the ratio 12 ratio 16. That's by mass now. And if I should divide this, I have 4 here 3, 4 here 4. So that's 3 ratio 4. And here, if you look at it, I have 12 ratio. Oxygen is 16. I have O2. That's 2 of 16. 2 times 16 is what? 32. And if you look at this, what can go here? Okay, if I use 4 here will give me 3. And 4 here will give me what? 8. As you can see. Now check. Look at these two ratios. You observe that carbon will not change. Carbon did not change. Now let us bring the various masses of the second element here, their ratio. Here I have 4 for oxygen. Ratio here I have 8 for oxygen. And if you observe 4 here 1, 4 here 2. You can see that the various masses of the second element are in simple number ratio. That is just what they are telling you. So that's that for that on law of multiple proportion. It's very, very simple. So that's it. So don't look at the one that is changing and bring their mass together. You see that you have simple number ratio. See 1 ratio 2, simple number ratio. So that's that for that. Thanks for watching. Now, let's verify law of multiple proportion in this video. Let's look at this question. Copper forms 2 oxide, copper 1 oxide and copper 2 oxide. When known masses of these 2 oxides were reduced in a stream of dry hydrogen gas, the following results were obtained. So look at it. You have copper sample A and B. You have sample A and sample B. Now look at it now. Look at the oxide and look at copper and look at oxygen. Now, how will you verify this? If you have to verify law of multiple proportion, what should you do? Now pay attention to this pattern. It's good to have a pattern when solving. You'll be very fast. Now the pattern is this. Look at the 2 elements reacting and take a fixed mass of one of them. Look at the 2 elements reacting and will take a fixed mass of one of them. Anyone at all. So if you observe this question, you see that 0.16 gram for sample A. 0.16 gram of oxygen is reacting with 1.28 gram of copper. You can see 0.16 gram of oxygen reacted to 1.28 gram of copper, right? Good. Now take a fixed mass of one of them. So I want to take a fixed mass of oxygen. You can use copper, anyone you want, but pay attention. For easy calculation sake, take a fixed mass of the one that have the smallest mass. You can see this mass is smaller than this. Yeah, you can use anyone, but I would advise you to take the one of the smallest mass. Why? So that for easy calculation sake. Yeah, there's a reason behind that. So let's go. This X all together. So remember, I'm taking a fixed mass. This is like a fixed mass of oxygen. Are you there? To react to X. Now find this X. Now let's go. Now cross multiply. What you are doing here is cross multiply. 0.16 times X will give me 0.16X. Then equal to 1 times 1.28 give me 1.28. You are looking for X. Divide both sides by 0.16. Divide both sides by 0.16. Cancel. Therefore, X will be equal to what? 1.28 divided by 0.16. This will give me 8 gram. Now, pay attention. The reason I told you to take the one of the smallest mass as a fixed gram, as when you have taken this one as a fixed mass, you'll have been getting 0.16 over 1.28, and that will give you about 0.125. You will now be dealing with decimal, and you can fall into error. So the best one that will take the one of the smallest mass to be a fixed mass. Good. That's now good. That's for sample A. I have 8 grams of copper in sample A. Next, for sample B, you observe that was 0.40 gram of oxygen react to 1.60 gram of copper. So 0.40 gram of oxygen react to what? 1.60 gram of copper. Remember, I'm taking oxygen as the fixed mass. Whichever element you take as the fixed mass on sample A must be the same as sample B. So 1 gram fixed mass of oxygen will give me X for copper. Now find this value of X. Let's go. So what you are going to have here is your cross multiply. 0.40 times X is 0.40X. 1 times 1.6 is 1.6. So what do you do here? Divide both sides by 0.40, divide both sides by 0.40. So cancel. So X here will be equal to what? 1.6 divided by 0.40, and that give me 4. Now what will you now do to now verify this law? Now pay attention. What you are going to do to verify this law is this. Now to show that this law obey law of multiple proportion is that what? Now let us take the ratio of copper in the first 2 samples. So in sample A and sample B, now what's the ratio of copper there? If we can get simple number ratio, then we are correct. Now in sample A, the mass of copper is 8 gram. In sample B, the mass of copper is 4 gram. Now gram cancel gram, 4 here 1, 4 here 2. Therefore my answer is 2:1. Now since we got a simple whole number ratio in both samples, then law of multiple proportion is obeyed. That is it. Thanks for watching.